All right, I have sad news for everyone. If you are absolutely in love with super long videos, this is not the video for you. We're going to talk about intercepts. So remember that x-intercepts are just when y equals 0. Y-intercepts are just when x equals 0, right? X-intercept is where it intersects the x-axis. But any intersection of the x-axis, right, the y-coordinate here is 0. X-intercept means y is 0. Y-intercept means x is 0. That's basically this whole video. So let's do some problems. Example 2. Find the intercepts. And in a lot of these problems, I don't remember which ones. Some of them only want you to find the x-intercepts, but we're going to find both for extra practice. All right, and it's more useful, and we're going to have to find both in the next section as well. All right, so f of x is equal to x minus 2 times x plus 1 times x minus 4. So again, the x-intercept is y is equal to 0. That's going to be when 0 is equal to all this stuff. And luckily for us, this is already factored. We use the principle of zero products to immediately get our x-intercepts. Oh, x is positive 2 and negative 1 and positive 4. Beautiful. And the y-intercept is when x is equal to 0. So if x is equal to 0 here, what do we have? Y is going to be 0 minus 2, 0 plus 1, and 0 minus 4. So the y-intercept is whatever this multiplies to, which is positive 8. We got our x-intercept, we got our y-intercept, done. So this is a good situation if it's already factored. If it's not factored, you're really going to have to work on your factoring skills. So let's look at something like that. Really show you 2 different things that can happen here. And again, we'll show more in the next video sections videos. What about f of x is equal to x to the 4th minus 4x squared minus 45? So this one's kind of tricky to factor because there's an x to the 4th. We're still going to want to factor it eventually. May as well factor it now. Okay, so we're going to say, okay, this is a trinomial. There's 3 terms. We try to take out a common factor. They don't have anything in common, so we can't do that. If there's no common factor and it's a trinomial with leading coefficient 1, we know it's going to look like this. X to the 4th means it's going to be an x squared and an x squared. Then we need something that multiplies the negative 45, that adds to the middle coefficient, negative 4. Maybe you don't know what that is. So just list the pairs. It adds to a negative, so the negative factor is going to be bigger. We could try 1 and negative 45. Well, these add to negative 44. That's not it. 2 doesn't divide. 3, negative 15. Nope, that's not it. 4 doesn't divide. 5 and negative 9. Oh. Add these together, you get negative 4 just like we wanted. So those are our choices. Plus 5, minus 9. And if you're ever unsure, check your answer by foiling. Okay. We can factor this again as well. This first one's prime, x squared plus 5. The second one is the difference of squares. It's going to be x minus 3, x plus 3. Now this is fully factored. Okay. So our x-intercept is when y is equal to 0. That's going to be when x squared plus 5 is equal to 0, x minus 3 equals 0, and when x plus 3 equals 0. These second 2 are very easy. X is going to be 3 and negative 3. This first one's not quite as easy. You have to subtract 5 over. Get x squared equals negative 5. Take the square root, you're going to get x is equal to plus or minus the square root of negative 5, which is not real. Plus or minus the square root of 5i. That means it's not going to intercept over here. So actually, these are our only intercepts, okay? Not real. So these are solutions to the equations, but not an actual x-intercept, because we only have real axis so far. There are such things as graphing complex numbers, but that's not what we're going to do here. So these are our only x-intercepts. The y-intercept was when x is equal to 0. You can either use the factored form here or the original. Plugging an x equals 0 into the original is much easier, I think, but both work. Right? When x is equal to 0, we get 0 minus 45. Y is just that negative 45. Or if we plugged in 0 here, we would get 0 plus 5. Well, it's 5. 5 times negative 3 is negative 15. Times positive 3 is negative 45. All right, so that's another way of getting your y-intercept. But either way, we get our x-intercepts and our y-intercepts. And again, for all of these, you really can be checking your answers with Desmos. It's a great way to visualize what's going on. Okay, so let's just do the one we just did. X to the fourth minus 4x squared minus 45. What's that y-intercept? Negative 45. That's what we said. What are the x-intercepts? 3 and negative 3. And there aren't any more. So we can really check our answers and make sure that our intercepts are correct. All right. Do the last one. Part C. Okay. Going to be f of x is equal to 2x cubed minus 6x squared minus 20x. Again, this is a trinomial, but this time there's a common factor. Okay. We can take out a 2x from everything. Take out a 2x, we're only left with x squared here. Take out a 2x, we're left with a minus 3x. Take out a 2x, we're left with a minus 10. We can factor it again. The 2x stays there, but we can factor this trinomial. Multiply to negative 10, add a negative 5. We get minus 5 and a plus 2. This has 3 factors, which means it's probably going to have 3 intercepts. So for the x-intercept, that's when y is equal to 0. That's going to be when x equals 0, when x is equal to 5, and when x is equal to negative 2. Don't forget the 0, right? If x is equal to 0, this whole thing becomes 0, which is what we want. And then the y-intercept, again, we can just plug it into the original equation. When x is 0, well, that's 0 minus 0 minus 0. I can do the math very quickly. It's 0. So these are our intercepts, 0, 5, and negative 2. Let's see if we were right. 2x cubed minus 6x squared minus 20x. The intercepts are negative 2, 0, and 5. Those are our x-intercepts. Good. And the y-intercept, well, the y-intercept is also right here. Y equals 0. Checked our answers. We're good to go. All right, and that's how you find intercepts.